Hi guys. Yeah, I'm Lib. I'm Lib. Okay. Hi guys. After a big break, welcome back here. I'm really glad to be here, and I see how many of you are here with us. My name is Zsuzsi. You've already met me before. I am the organizer of the Rust Meetup. I work at Mimox Kft. For 3 years now. We are a recruitment company from 1999, and we organize and participate Rustfest also. Hoping a lot to have clients who are looking for us developers in the near future. And I hope it's not a dream in Budapest. But now I would like to speak about Stefan Schindler. Thank you, Stefan, to accept my invitation to give a talk on our meetup. We already met also Stefan. Hello. He was a Rust meetup speaker in Budapest before as well, and he is one of the Rust Fest organizer. So you can ask him also about the online Rust Fest from November. It's a really fresh story, but now he is going to speak about one-factor authentication. Yeah, so thank you, Stefan. You are on the stage.
Thank you. Really happy to be back. Welcome, everyone. Quick about me. I've been doing Rust for a little over 5 years, already it's 2021. Yeah, and I started with a chatbot, actually. That was the first project that we wanted to migrate from a very often failing Python implementation to something that would not constantly require us to restart it. And ever since, I've been looking at many things. And today, this is less of it. This is all the things we have in Rust, and this is how it's done in Rust. This is also like the whole other part over here that we'll need both. We need to connect these two worlds so we can have a system that actually works. Zsuzsi? Yes, thank you very much. So the one-factor authentication prototype or proof of concept, I proposed that in fall to colleagues at the university, and they said, okay, let's have a look at it. And then we dug into this project. Was with Marco Stadler and Stefan Kopfhammer. Credits to them also for working with me. And we discovered there's a multitude of one-factor authentication, or let's not say one-factor, but like passwordless authentication, because that was my original pitch. So what is the things we do? So we'll go over this quick history, and then we'll look into what do we need, and also look into the proof of concept. Then I will quickly talk to you why I built in a container, and then we'll have a lot of time for your questions. So, what do we need? What gives us security? It used to be just knowing where stuff is, right? In the very early internet, in like the 70s, so few computers existed globally that we could just say, if we know where something is, we can have access to it. The internet wasn't a thing for many things. There was many competing standards like IP and Netlink and IBM stuff and Apple stuff, and none of them were compatible. So if you wanted to reach something, you had to be on the physical location. So why bother? And also, how many people knew what to do with the computer? So usernames, that was a thing that didn't exist in the beginning. But over time, interconnectivity grew, and we added more and more stuff until we are here today, where everything is connected. Even your toaster can talk to your fridge. Whether that's a good thing or not is another debate, but that's where we are. So what gives us security today? It's entropy, more or less. How much guessing does someone we don't want in our system have to do to get in, although we don't want that? So what alternatives do we have to passwords? Right? Because that was the standard thing. At some point, people settled on this, like, yeah, username, password, good enough, right? 5-character passwords should be enough. Or these, what Android had with the maze, where you had these graphical passwords. Or biometrics. Biometrics is easy, right? You don't have to remember, just have to look the same all the time. Why just use like one password for all the services? Why not just have one service that does all your passwords? So we had the federated single sign-ons. There's many services of those, and we'll talk about this later. So this XKCD, probably many of you have seen it already. Let me quickly scroll to the number. Dun, dun, dun. XKCD number. Wait, I'm sorry. I have skipped all of the slides. Quick history. There we go. This is what I wanted to show. So, the 5 most prominent hacks in 2020 were probably Zoom. They didn't exactly say what was hacked, but apparently lots of data was lost. LiveJournal, I've never heard of, but apparently it was password stuffing, which means they gained passwords and username combinations from one site and used them on some other site. Twitter was hacked more than once. I think the funniest one was when an employee did something to ex-President Trump's Twitter account. Wishbone and Instagram, of course, attractive targets, but yeah. So another fun story is the most common passwords in 2020 are these. And to my surprise, 4 zeros isn't on the list anymore. Probably because a lot of programmers forbid this password. But these aren't that hard. However, we can see in the top 20, there's always at least 6 digits or 6 characters. So there's some improvement. I think the last survey I've seen was from 2015, where we had 4 digits. So yeah, it's something. And we covered this already. So this is hard to read, but basically authentication is, we don't want to know that the system is talking to us actually belongs to the person that it says. So we need something that the human can carry with them, either knowledge, something in possession, like a smart card, or a feature, like a biometric feature, or a behavior, like the typing, the kind of typing you do. There's a very interesting article written about 2 years ago, where they analyzed how easy is it to identify people by letting them type a sentence just from the rhythm of the people. But biometrics, and this is this slide, we have all of these kinds of biometrics, right? They all have the same problem. We're not machines. We're not always the same, right? If we, let's say, make Face ID, we have to be fuzzy as engineers because people sometimes are tired. Sometimes they stand in the rain. Sometimes they just age. And aging is a real problem because how can you differentiate 2 siblings, right? How can you differentiate an older from a younger sister or twins? Hard problems. And then sometimes, can you even distinguish parents from their children? Because when they dress similarly and look similar, We have to be fuzzy, and then there is an amount of data that we want and an amount of data we don't want, and the overlap of this cannot be too small, because otherwise people will just say it's broken, it doesn't work all the time. So we have to be a little fuzzy and give little headroom, and this headroom is what attackers can use to infiltrate systems which they should not have access to. Another thing is with biometrics, you cannot change them, or it's really hard to change them. I mean, you can sometimes change your biometrical behavior. For instance, if you have a door that identifies you by the kind of walk you go into, right? What happens when you break your leg? Suddenly it changes, the system doesn't recognize you anymore. What if the system is trained to recognize your broken leg? Can someone just tape their leg so it looks the same to the system? And in the end, what happens if the data is leaked? Because at some point, enough data about people will be leaked. Can we change biometrics? We cannot. We can just switch to a new thing. So when we use up fingerprints, we can then maybe use iris scans, but at some point, someone will make an iris database, maybe build it up from the passport pictures database. What then? Well, we can use ears or nails or lips. But do you really want to wait for, and then in 20 years, the government is like, oh, well, now for more security, you have to kiss some pad every time you want to use your passport, for instance, for boarding a train or something. So biometrics, yeah, it works for now, but I wouldn't trust it. Moving on, let's see if this works correctly. Yes. So single sign-on. The most common in the public internet nowadays is probably OAuth second version. It has multiple flows and you can revoke access. The application has to handle revoking access during a session, but apart from that, that's pretty good. There's an older standard that's used at universities a lot. It's called Shibboleth. It basically does the same. I think I have a picture for that. No, we don't have a picture for that. No, going back. So what all of these services have in common is the client requests access to your server, and your server says, no. You have to authorize first. Here's a list of identity providers. With OAuth, this could be Google or GitLab or GitHub or something. With Shibboleth, this has to be a university that the application trusts. And in the end, it doesn't really matter because they all sign a random token. They hand over to the client. The client goes to the identity provider or chooses one from the list, goes there and says, okay, I want to be authorized for this application. The identity provider can then decide whether or not this request can be granted. Not always. I mean, with Google, you're pretty much allowed to try to log in anywhere. With Shibboleth, for instance, you're only allowed to use university services. You cannot use it for your bank or something like that. If the login, usually with username and password, is successful at the identity provider, the identity provider will then sign this token as well, hand it back to the client, and the client can then take the signed and present it to the application, which then can verify the identity profile. The identity provider signed the token as well, and then let the user in, and also knows what rules to apply, because the only thing the identity provider says is, this is this user in these groups. Do with it what you want. Right. So, coming back to this, why should we do that? Why use something as complicated as a single sign-on or any third-party service? Let me just, I'm sorry for that. So this is XKCD 936. Passwords are hard because they need to be very secure. How much security do we need? We need roughly 60 bits of security. Well, how much do we need? How many different choices do we have? So this is the example with the English alphabet. So this is just lowercase letters and some punctuations and spaces gives us 28 bits of entropy per character. Sorry, is that right? Yeah, I think that's right. No, wait. Oh, can't remember. Dun, dun, dun. Yes, 28 per character. So in theory, we would need 4 characters. So it should be sufficient for breaking through this thing. But we all know that doesn't work. What's the current recommendation? Well, according to OWASP, it's 12 characters for a password, and it should look like this, like the one on the top left. Troubadour and free. But many people use common substitutions like leet speak. Many people just use their dog's name, their birthday, or just the same password for all the things, even if that password is password, as we have seen before. So this comic proposes that we use full words, right? We just spell them out. And this gives us way more entropy. This is pretty great, right? Because it's easier to remember. But what I would change nowadays is, why does this have just to be the nouns? We can use all of the sentence, like full with adjectives. You can have this as a password, right? The sentence, "It's a beautiful day and I like ice cream," as a sentence with spaces and the dot at the end is a great password, which you can remember far more easy than whatever this cryptic thing is. Plus, it's like 50 characters long, so that's great. There's some disadvantages, like there is a couple of systems, especially in banking, that still store plain text passwords nowadays. I found that out yesterday when I called one of the banks that holds an account for me, where they said, so now we would like to have the third, the fourth, and the fifth character of your password for authentication. And it was just like, great. I'm really thankful for using a password manager, because that password is basically burned. It's obviously stored in clear text in their database. So that brings us... Why is this not working? There's another slide missing. Okay, so quick checklist. What do we need? We need passwords that are stored safely, aka salted and hashed. There are some people that go further and say, okay, we need passwords that are also peppered. Pepper means that the hash is enhanced with another value that's stored in the source code. The idea is, if someone is able to leak your password database table, then they don't have access to the pepper, which is stored in the source code, ideally. It's true sometimes in the cloud, sometimes it's not. It's just another measure. But we want at least having salted hashes. And then we would prefer to actually store even less, right? If we can, then we just store an identifier that will hand off to another service. And then we're back to single sign-on. But then we need to be very friendly to the users, because people will not like us if we just say, hey, here is like a 128-bit identifier. Why don't you use that as your username? I mean, it's basically a password, so it doesn't matter what you choose for a password, but remember this 128-bit value. So they still want to use email, and we can use the email for notifications and stuff like that as well. And in the end, let me show you this. it should look like this, more or less, right? We have a login form that just asks for the email address, and the people will be able to click login. But I'm getting ahead of myself. So let's go through the development stage. I'm really sorry for the bad readability. So this is where Stefan's Rust tips come in. I assume many of you have used Cargo for building Rust project. It's the package manager. We can also have add-ins. So this one is the Cargo Watch add-in. You can install it with Cargo, install cargo-watch. It will install a binary in your user's home folder, which then extends Cargo, and you can say Cargo Watch, and then with X we can say different actions. So the first action is check. Check means it compiles all your dependencies in debug mode and then tries all the steps but the linking with your code. So the dependencies have to build, and your project would most likely build. It will be syntactically correct if this stage passes. You get all the fancy error messages of Rust, and it's really fast. So Cargo build takes, with this project, roughly 30 seconds, which is very long for immediate feedback from the compiler. With check, it's done in less than 1 second, which is great. I mean, after the initial build. The initial build depends on the 300-something dependencies I have, but after the initial build, check is really fast. Then we have FMT, format. This will format the Rust source code in a standard way. This is great because then I can type the Rust code fast. Don't have to spend time like indenting stuff. If it's syntactically correct, which the check step made sure of, format will format it always the same. So the source code will always look the same. And my editor is smart enough to notice the file change and just reload the file. Unless I change something, then it will be like, hey, something has changed. You can either overwrite it or load the changes from the disk. Then we have test step. This depends if you actually have tests in your project, but for the default, it's a great idea. Just run all the tests inside the Rust source code. And this is run every time you change some code. But every time I press Control S, it will check, format, and then test the thing. And finally, if all the tests pass, it will run the project. Since this is using ActX, this project, the ActX is smart enough to let itself be killed once the Cargo Watch detects a change. That's really handy, so we don't have to kill the web server all the time. We can just have the browser open with our website, the terminal open for the error messages that are from either the compiler or our own application, and then just edit in a fork window. So, what did I use? As I mentioned before, I use ActX with some of its add-ons. I used ActX ID, ActX Identity as the session storage. But this just handles that all the clients that have any contact with my service get they get a cookie that's I don't remember, pretty long, at least 64 bits random value, and just store that. Set all the flags, make sure it's safe, that the JavaScript VM cannot access it, and I can. I fixed that. I just looked at the code. It's a 128-bit random value that's assigned per client, and the clients will just bring that ID back, and then I have my own little database, aka hash map, that gives me back the session state for each step. Then Terra is a templating engine. It's pretty smooth. It can write almost HTML. It's based on the ideas from the Django framework. So you can have small loops, if else, and imports. So you can actually layer the template. So I have a base template, then all the other sites I have use the base template, or almost all of them use the base template, and then just insert blocks of HTML into the rendered output. Serde, I use Serde here, of course through the framework, but then I wouldn't have it directly. I use Serde for configuration. So all of the configuration that is done for this project is stored in JSON files, and they're just loaded on startup. I have three special kinds, Serde and compound duration. They allow me to store the standard duration and standard instant in a JSON value, which the standard Serde does not implement. Then I have Mailgun, because a mail transport can be hard. It worked on my first tests, didn't work with another mail provider, so I switched to having a remote API. I'm not 100% sure if I would stay with Mailgun, but it's one of them. It works. You can use any mail provider with ease that has an HTTP interface, preferably a REST interface. So you can have a token that's stored in some configuration file, and then just whenever you have a request, pass that on to the REST service. And then, of course, rand for random numbers. And then this has been cut off, sadly. Lazy static enveloper and identicon. Identicon I will show you later if I don't forget. It's just a little extra touch, like give the user some personality, like, hey, I don't have space for your long email address all the time, but hey, here is a picture that identifies you, that you can remember, maybe. By the way, almost forgot about this. Thanks for the slide. I had to extend this crate, and thanks to it being open source, I was able to do that, because for the university prototype, I needed to use European services because we have to be GDPR compliant. So I was able to extend this crate, and it was actually merged, and it's released in the version 0.10. If you want to use that, just update. It's not my crate, just someone was kind enough to share. Moving on. So, building. We have our source code now. It works on my machine, and then I deploy it to the server, and it doesn't even start. So what is this? It's classic case of, well, I have Arch on my local system. There's a Debian installation on the server. libc doesn't work. This is a very common error if you deploy without containers. There's two ways around this. One, you can build a container. If your server supports containers, you can just point the server to your container registry, tell it to download the container, and be done with that. In my case, that doesn't work. I want to have a binary that's naked in the file system path of the Linux. So I'm going to use rastup for the compiler, cargo for all the testing before, and then Docker. I want to switch to Podman, but it's been a busy year. And in the end, the goal is to have GitLab with the GitLab registry ready. So it presents the container, and then I can just clone the container, pull it down onto the server, and let it run, and injecting the configuration with overlays. That's a very cool thing. So you can just tell your binary, hey, this is the path of the configuration file, and then point that into a folder, and that folder can be overlaid from your Kubernetes or K3S environment. So you have a shared volume that's like read only to the container, read write for you. All your configuration is separate from the binary. If you update the binary, configuration is untouched and reused. It's pretty great. In our case, we need to have a binary in the end. Lucky for us, Rust gives us static binaries, so we just have one file and all the static resources, but rsync is fine for that. So let's have a look. I use a Makefile for that. Those of you who are longer in IT maybe remember them. There's a large debate, or there used to be a large debate about CMake versus Make. In my opinion, Makefiles are just more convenient way than writing a bash script, because I can have multiple targets in one file. I don't have to do argument parsing all the time or weird switch statements. So this is that. So building in a container, first I have to touch source. Why, I will tell you later. Then we have this Docker run. We want to use a container that's removed after the run. So we don't want to have lingering containers on our local system. Because, I mean, this laptop has 1 terabyte disk, but with each container weighing around 500 megabytes, I would run out at some point. And this way I don't have to worry about this. User means that we map the current user and group to what's inside the container, the root user. That is working for the most part. And yeah, we still need to touch it up, as we see in the next line. Then we map the current project into user source my app. This is just a convention that the Rust container uses. And then we tell it, okay, yes, we want you to work inside this container, inside this folder, with this image, Rust latest, from the Docker Hub, and then run this command, cargo build release. This is the normal cargo build command, just running inside the container. Why do we do that? Because this container here is built based on the Debian base image. So all the libraries match up. So the Debian base image on my server that's used is the same as for this container. Hence the binary build. In the end, sadly, this doesn't take all the files, because the artifact at the end and some files are still created as the root user instead of my local user. I have to change ownership of the release folder and the binary. Also, you can use variables like this in the Makefile. And then we'll deploy directly. We'll just SSH into the system, use systemd to control, to stop the service. There's a $sign missing here in the presentation. Sorry for that. It's in the real Makefile. And then we'll rsync all of the files. We'll have our mail config that's synchronized. So we have the secrets that are for the email configuration. We will synchronize them over. The release binary, the templates. This is all the things the Terra needs, and static. That's the JavaScript, the pictures, and whatnot. And we'll put them onto the host with the username in the home folder of that user. And then in the end, we'll say make systemd restart. The systemd restart is another rule that will just SSH into the host and restart the service again. Okay. Remember this touch from before? Well, this was because we have BuildRS. BuildRS is used for a very handy little feature. It's imprinting the Git version and the Git tag into our binary. You can then see that on the page. Let me just quickly reload this. See down here, version 4.0. Also, I did just do a login. Sorry for spoiling the demo. How is it done? BuildRS is run every time cargo is run, and it will send, will start a command. It will use the git command with describe, and the arguments for the describe modules are tags and dirty, which will give us either, if we're on the tag itself, it will just give us the name of the git tag. And if we're above, if we're like committed onto the version, it will show us this is version, let's say 040 on this git hash. And if we have uncommitted changes in the tree, it will add -dirty on the end of that. We run the command, and then if it's successful, we'll map it to standard out. Sometimes people clone the code, then they have Git. Sometimes they just download the zip version and don't have Git installed. Then this fails with a bit of a cryptic error. So the second step is, if any of the previous things fail, I will just use what's stored in cargo, the package version of cargo, and append -unknown, because we don't know on which commit we are, -dirty. It may not be true that it's dirty, but usually when people download a zip file of source code, they make changes to it, so it's safe to assume it's dirty in some way. Up until now, this has all been internal. Nothing has been handed over to cargo. So now we have to output information to cargo, and this is just done with println. So we say cargo rusts env. So we want cargo to add an environment variable called git version, and that's equal to our string, which is either what we parsed from the git command or our fallback. And then if we just did this every time we change something, so for instance, if we change the HTML or a JavaScript file or CSS file, this build process is run again, and the output is different. Therefore, it has to be linked again, which again takes 30 seconds. So if I'm developing my UI components, I would rather have a fast reload of the server than waiting 1 character in an HTML file. So we add this rerun if env changed, and then say git version equal the same thing. Only rerun if this environment variable changed. It's not working perfectly, so that's why we have to touch the BuildRS source code, because if the BuildRS has been modified more recent than anything else, it will be rerun again. It will trigger this change, and then it will actually build with the current version. It has been a learning for me. I'm not sure how we can improve that, but yeah, future works. So now demo time. As we have seen before, this is the demo. You can try it for yourself right now, actually. I opened up the verification so everybody can try it. Let me quickly see if anyone did. No, just me. All right. So what I did is just enter my email address up there and press login. And then this is not great. It's a proof of concept, but it says what happened. So were we able to send the email? Because sometimes our third-party email provider is not able to be reached, right? We cannot reach it. We cannot find it. Maybe they have TLS errors. This time it worked, and they responded with success. They said cute, thank you. And this is the ID of that email. Now let me check on my email. I got a little mail back. And it's really slow. And I show you this. Do you see that? Oh, okay. There's apparently a little problem with StreamYard. Doesn't work. No matter. So we will just open a new tab with this email address. So it sends us an email that guesses our name. It just uses the part in front of the app and then says, click this link to access your account. And this is the link I copy pasted in here. And then when we do, it says, hooray, your current session state is logged in. Welcome to the system. And now, because this is the first time I've done this, I can go to our profile and see we did a login from this address, which is the IP version 6 of this laptop. And here we can see the identicon, the little gimmick for people. This is just based on the email address. So now if we log out and log back in, it sends us another email. It says, hey, it's cute again. And after I get the other email address. Oh, I accidentally deleted it. Very sorry about that. Clicking on the link again gives us back our access. It's not just a scam, so we can also just go back. This is the old email. We can just press on the main page. Since it's cookie-based, we are logged in again. Okay. This was the demo. Do you have any questions? See, someone has shared the link in the chat already. Enjoy the demo. Yeah. I think Susie and I will be here in case there's questions. You're muted.
Okay,
of the last year, you're muted. Oh no, she's gone.
I am. Okay, I'm here again. So any question maybe to Stefan about anything? I'm just joking.
Well, one question that might come up if you see this as a recording, I might have to shut down the service in the near future because I might run out of the free quota of emails I have on this account. So
maybe my baby will have a question here.
Oh.
He just came into my room. So sorry.
Cute. Oh, I see someone is typing.
Yeah.
I didn't pay too much attention during the talk. Did someone ask a question during or?
No. But there is a question here. How much time did you spend on it till it worked? That BuildRS Git hack was interesting. How much time did you spend on it till it worked? Yeah. This is the new question.
Too much. How much was it? I want to say almost a day, stretched over 2. So I came across BuildRS and was just like, yeah, this is cool. I will add it. And then I was developing on the binary. So that was quick. And then the next day I was working on the HTML and I noticed that it was really slow and it took me quite a while to figure out why was it rebuilding all the time until I disabled the BuildRS again. And then learning about this hack, 4 hours at least, maybe 5. And as I said, it's a bit too reliable, so it just stops rebuilding everything until you have some change either in the source code or the BuildRS itself. So that's why the Makefile has to update the BuildRS every time you do a release build, because sometimes it happens that it does not include the new Git version or the Git tag. Yeah, hope this answers the question.
Thank you, Stefan. There's another question here. So is this meant to be a third-party service that other web apps use for authentication, like SSO, or is this project meant to be a library for Auth4Us projects?
So this is a very good question. It can go either way. One would have to refactor the login procedure into an ActX module. So you can just plug it in as a middleware, which I didn't do because I didn't have a real application, right? The application is showing your login attempts and when you did it. So for SSO, it's if you trust the connection between your service and the OneFA service, then you can just take the credentials from the user and forward them to the other service, like any man in the middle. And then when the user submits the email that was verified, you could react to that and then go back and let the user do what they're supposed to do or not. In the state that's currently in, it's more on the path of a library because we don't have any of the cryptographic implementations that we get from OAuth or Shibboleth. Why is this still useful? It's very useful because how much security do we actually gain from building a system that has an internal database for passwords and all the logins and stuff like that? We still have to manage the roles, right, with this system. But all these systems that use email address are as safe as the email provider. And if you have a reset account link somewhere in the application, it doesn't really matter where you are. If someone guesses the email password or has access to the email account of a victim, they can log in any service because they can reset the password. So the question really is, do we actually need to force the user to remember yet another password? Or can we just say, hey, look, the session timeout is quite high. There's a button up here for logging out if you don't want the session anymore. But in the end, the security level is not increased by having a special password for the service. We might as well just use the email address. One more thing, which isn't implemented because the project ran out of time, is let's say we are in a non-trusted environment, like you're on holiday somewhere in a hotel and they have this wonky computer, but you want to access this service. The next step is we type in our email address, click login, and it will show us, okay, it's pending. And then you take out your smartphone open the email on your smartphone and then authorize the session on the not trusted computer. So you can log in another system. I currently disabled this mode because it didn't match the requirements we had for the project at university. But in theory, it's absolutely doable. And the the basic structure of the code is already there. Right? We have WebSockets, and we can have the browser just have the WebSocket connection, and as soon as the smartphone validates the email address, we can then go back and authorize the user on a non-trusted device. Longer answer this time. I did see.
Okay.
Yeah. Is this the next question?
Yeah, what if the email arrives only after some minutes?
That can happen. The emails in the token in the email in this demo is valid for 30 minutes currently. For a production application, I would make this configurable. But in the end, that's a risk we take, right? As soon as we have a third party and that third party is unreliable, with email, there's more than one third party actually, right? We have the email gateway, we have everything in between, could be multiple hops for the system. Like maybe someone uses their university email, then this is one connection, then they have to forward it to some other email address, and then maybe they have this their business account and they have forwarded that to somewhere else. So it's multiple hops until it reaches the client, and the client still has to synchronize. Yeah, no risk, no fun. Ooh.
Okay. The next question is, do you not think that we are really a bit too much on email? There is a risk of someone's email getting hacked and potentially being logged out of every service on the internet.
That is correct. There's a talk from Tom Scott where he talks about the day that Google went down, and he proposes this exact scenario, actually with a little twist. He asks the questions: what happens if you don't need a password for any Google account anymore? What if some high-level employee on purpose makes everything accessible on Google? It's the same question. Yeah. You depend. In the end, it's a trade-off, right? You depend on either all the things doing in-house. You do all the things in-house. You have to be doing them right. If you have one error in your chain of security, the chain is broken. And when we include services or systems from outside our full control, we rely on them. So, yeah, if someone loses their email account today, this is really bad. And I'm pretty sure for most people there is such a single point of like trust, right? It's usually their first or their second email address. It's probably for some people it may be MSN or Hotmail, like something really old. For younger people, it's probably Gmail, or Apple Mail when they got their first smartphone and just use that for everything. So yeah, you can help avoid that a little bit by using two single sign-on services that you can authenticate crossover. Right, so you could build yourself a path out of this a little bit if you say, okay, I use single sign-on for Google that uses Microsoft and vice versa. So you can log in with one of the others into the account, but that doesn't solve the problem if the email provider decides to delete your account for some reason. Maybe the government issues what's it called, like an order to delete or hold your account, then you're done. That's true. Yeah. So yeah, the question is, what's more likely to happen? That people forget the password, that they use a weak password, or that the government decides to block their email address? Yes, I think that's the answer.
Yeah, here we are, the next question. Correctly, the muscle lips is also a viable solution for the different lips version problem. Have you tried maybe?
I used to build with muscle in the past, yes. I didn't do it for this project because, why did I not do it? Oh yes, there was a rumor that there are some problems with accessing the event loops with Actix, and I never investigated it, but yeah, it might work. It's definitely possible. In the end, I had systemd, which does all the nice things. So in the event I have a panic in the Rust program, systemd will restart the service automatically. I get log capturing and log rotation from systemd, all of these things. And it was at that point where I was just like, I could either build in a container for Moozle, or I could just build in a container for the standard Debian environment. And then it's already there. So that's the question. Oh, that's the answer.
Okay, so before the next question, I have to say goodbye. So we passed the. So thank you, Stefan, very much for your presentation. It was really, really good. And I really hope that we are going to meet in this year, next time, at another Rust meetup. And thank you, everybody, guys, who saw us. And if you have any further question, you can write it down into the chat. Stefan will be around and answer your questions. So thank you again and have a nice evening.
Yes.
Bye-bye.
Bye-bye.